Hello, good students. Welcome back to class. Today we are going to be looking at a very important question in physics: temperature and heat measurements per se. Please, if you know you have not subscribed to this channel, try and do so. And please don't skip any part of this video. The video will be very short and we are going to explain everything word to word. Please ensure you don't distract yourself by any means as well. Now, let's move to the question we have for today. The resistance of the elements of a platinum resistant table metal is 2.00 at the ice point and 2.73 at the steam point. What temperature on the platinum resistance scale will correspond to a resistance value of 8.43? That is the question. Now, if you want to solve questions under temperature as this, what you do is to apply the principle of interpolation. You draw out the two scales because you're going to be comparing scales here. We'll be comparing scales, temperature scales. Now, one will be calibrated in maybe degrees Celsius. We only compare that to degrees Celsius. While the other one will be calibrated in millimeters, centimeters, which will be for mercury in glass thermometer, or in ohms, will be for platinum resistance thermometer. Now, this 2.00, 2.73, 8.43 are basically in ohms. This one is 2 ohms, 2.73 ohms, 8.43 ohms, because the unit for resistance is ohms. Now, we want to compare this now to the temperature that will be measured if we want to use the platinum resistant thermometer to measure the temperature. In now, how do we now call the answer in degrees Celsius? If the ice point is 2 ohms, the steam point is 2.73 ohms. Now, which one will now be 8.43? Look at how to solve the question. Now, you first of all draw the platinum resistance scale. Then you now draw Celsius scale. That is what you do. You draw platinum resistance scale, you draw Celsius scale, because we are going to compare this one to Celsius scale. But depend on how they are presenting your answers. You can also compare to Kelvin scale, Fahrenheit scale. Now you can compare to unknown the known temperature scale that you have. But degree Celsius is very popular. That's why most textbooks will be comparing it to degree Celsius. Now, if I tell you what is the temperature of human body, you can easily tell me in degrees Celsius. If I ask what is the temperature for boiling point of water, you can easily tell me in degrees Celsius. So most people understand degrees Celsius very well. That's why we do compare to degrees Celsius. Now, for temperature in degrees Celsius, Celsius scale, ice point is 0 degrees Celsius, while steam point is 100 degrees Celsius. Ice point is also called melting point, while steam point is also called boiling point. Now, at steam point, Celsius scale will read 100 degrees Celsius. Take note of that. While at ice point, it will read 0 degrees Celsius. Also take note of that. Those things are very important. So if you are seeing ice point, automatically they are telling you that the temperature in that place is 0 degrees Celsius. So they may not tell you 0 degrees Celsius is corresponding to this, 100 degrees Celsius. No. They just measure ice point and steam point. So you just know that they are talking about 0 degrees Celsius and 100 degrees Celsius. So I can read the question, I interpret the question this way. The resistance of the element of a platinum resistance thermometer is 2 at 0 degrees Celsius, that's the of ice point, and 2.73 at steam point, means 100 degrees Celsius. What temperature now on the platinum resistance scale that will correspond to a resistance value of this? If 2 corresponds to 0, 2.73 correspond to 100. What will this one correspond to? That's the question. So you draw the two scales. 0 is the downside, that is the lower fixed point. 100 is the upper fixed point or boiling point. That is the melting point, boiling point. You can also call this one lower fixed point. Call this one upper fixed point, lower fixed point. Okay. Then we are going to have 0 degrees Celsius correspond to 2 from the question. 100 degrees Celsius correspond to 2.73. Now, what temperature on this Celsius scale will correspond to this 8.43? That's the question now. Now, some people draw it this way. You just draw the upper side 100 degrees Celsius, downside 0 degrees Celsius. It's still done. It's still correct. You just put 100 there, 0 there. But ensure that this 100 you are going to put in this upper side must correspond to this 2.73. 0 will correspond to this one. Then the unknown temperature here will correspond to this 8.43. That is still correct. Yes, you can just put 100 here, 0. You put 2.73 here, 2. Then you now put 8.43 at the middle. Then you put S at this midpoint here. But that one, the drawing will not be very, very valid, because you can check very well. 8.43 is higher than 2.73. So this drawing is better in terms of drawing to scale. The drawing is better. You cannot put we cannot have 8 before 2. It's not possible. It's 2.00, 2.7, 8.4 in ascending order, something like that. 0, 100. Then this one should be higher than 100. So I'll just tell you that the answer you're going to have here will be higher than 100. That's how it is. So this is the most correct drawing. Although if you draw it the other way around, you still get the same answer if you know what you are doing. So now, how do you not get the answer from this drawing? You use interpolation. What is the meaning of interpolation? Just solve a mathematics in this place and repeat the same mathematics here and equate the two. That is all. While mathematics we do solve here, I like picking the unknown temperature first. And if you can also pick the unknown temperature first, you are good to go. We will just say this unknown temperature minus lower fixed point divided by this 100 minus lower fixed point must be equal to the same thing here. What corresponds to the unknown temperature? This minus the lower divided by this minus the lower. That is all. What you just do in this place, you repeat it here. That is what is called interpolation. So you have x minus 0, got it here, divided by 100 minus 0 must be equal to, repeat the same thing here. S corresponds to this minus this corresponds to 0, divided by this minus this. Then you're going to have this. So after this, what is going to be x? Now let's try and see what will be x. Alright, you'll be having x over 100 divided by 6.43 over 0.73. So if you revise, you're going to have this. So the next thing, s will not be equal to equal. Apply this 100 times this. 100 times this. S will be equal to 100 times this. Then you have this. The 100 times this is going to give us 881 degrees Celsius. Or you can apply this formula. Now, how does this formula works? The unknown temperature on the centigrade scale will be equal to resistance at the unknown temperature minus resistance at ice point or 0 degrees Celsius divided by resistance at 100 degrees Celsius or steam point minus resistance at that ice point as well, which is 0 degrees Celsius. Then times 100 degrees Celsius. Take note of that. Now, from this question, the resistance at the unknown temperature was this. That at ice point was this. At steam point was this. Then ice point this. This and this are always the same. So I'll be at for steam point, so I'll be for the unknown temperature, which we are looking for, which is this x. Some people use theta, they'll put theta here. Some people use t, they'll put t here. Just forget about that. That is labeling. Also, just what you have to use to understand the formula. Then multiply it by 100, you're going to have 881 degrees Celsius. So that you use this formula to solve it, or use that interpolation directly. You can just use one directly or use that interpolation, anyone you like. So this is how it is done. Thank you. God bless you all.